We're going to continue with limits at infinity, but we're going to look at some more difficult problems today. The first problem gives me a hint. You always want to use the hint whenever it's given to you. And the hint says, let x be 1 over t, and then find the limit as t approaches 0. So we're going to go ahead and do that. The limit as t approaches 0, and our x is 1 over t. And then we have tangent of 1 over t. What this ends up giving me is 1 over t times this 1 divided by 1 over t is actually 1 times t over 1. So this would be the tangent of t. I don't know a whole lot about tangents, so I'm going to change it into sine and cosine. Sine of t over cosine of t. Now, if I go back and I think about some of the things that we've talked about earlier this year, I actually could rearrange this. So it says sine of t, I'm moving this over here, over t times 1 over cosine t. Now I can use my properties of limits, and I can separate and think about each one as a separate entity. So I've got sine of t over t times the limit as t approaches 0 of 1 over cosine of t. This one is one we're supposed to memorize, and we know that it approaches 1. And then we have times. We did this one earlier, so if I put 0 in here, I get 1 over, what is the cosine of 1? Or cosine of 0? The cosine of 0 is 1. So we end up with our answer of just 1. In the next problem, again, I have another hint, so we want to make sure that we use the hint. And it says, express this as a denominator of 1 and then rationalize the numerator. So I will do that. So that means I'm going to be multiplying by 2x plus the square root of 4x squared plus 1 on the top. And on the bottom I have 2x plus the square root of 4x squared plus 1. What this ends up giving me then is the limit as x approaches infinity. And I'll go ahead and start multiplying those things together. I get 4x squared. And then the outer terms fall out, so I have minus 4x squared plus 1 all over 2x plus the square root of 4x squared plus 1. Well, looking at this a little bit closer, I have 4x squared and I have a negative 4x squared. So I now have really the limit as x approaches infinity of negative 1 over 2x plus the square root of 4x squared plus 1. Now if I just start plugging in infinity down here, I'm going to get a really, really large number. So I'm going to have negative 1 over a really, really large number, which means it will go to 0. In my next example, I have another table, and we can use the table function of our calculator to help us out. So we'll put this in our calculator, and then we'll hit the table button, and we'll go ahead and complete the table. I'll just go ahead and tell you what the table ends up giving you. You end up with 200. The next one you get 0.348. Then we get 0.101. Then 0.032. Then 0.010. 0.003. And then finally 0.001. Easiest thing to do again is use that table function on your graphing calculator. So once we've completed the table, it says to check using your graphing calculator. You should see that the limit as it approaches infinity, or as you approach infinity, it should be getting closer and closer to 0. And then we'll do this analytically. Finding the limit analytically, I'm going to use the L'Hopital's rule, which says I keep the highest degree on the top and I keep the highest degree on the bottom. This on the bottom is actually x to the 3/2 power. So when I simplify this, I end up getting the limit as x approaches infinity of 1 over x to the 1/2. So when I plug in infinity, I get 1 divided by a really, really, really big number, which means it's going to infinity. All this is meant to do is show you either way, if you do this numerically, if you do it graphically, or if you do it analytically, you still end up with the same answer as of 0.